Okay guys, so we're going to go through this lesson, and you'll do your notes just like if I were here today, and if you have questions, just jot them down, or you can send me an email or whatever, and I'll just check it, but hopefully this will answer all of your questions. So we talked last time about doing scatter plots, and we talked about the different aspects of how you would describe one. One of the first thing we talked about was strength, whether it was strong, moderate, or weak. And then we talked about the association, whether it's positive, negative, or none. So the correlation goes along with that. I told you yesterday that we would be calculating a value that would give us an indication about the strength in the form. And this is what that value is called. It's the correlation coefficient. So this value is signified by the letter R. So the correlation coefficient, we use R to indicate that. It measures the strength and direction of the linear relationship. So that is important that you notice that this only works with linear. If it is a non-linear graph, you cannot use the correlation coefficient because this is only for linear. That's why it's important not just to do the calculations and then just go on and describe everything, because you need to look at the scatter plot. You have to look at the scatter plot to see whether it's linear or not. That's the only way to tell. So you still have to do the scatter plot. You still need to graph it, see if it looks linear, and then if it does, then you can calculate the correlation coefficient. That will be an indication of the strength and the direction. On those that are strong relationships, it's going to be easy to tell just looking at the scatter plot that it's a strong, linear, or non-linear. You're going to be able to tell easily if it's positive or negative. But the ones that are moderate or weak, that's where it gets really difficult to just look at a scatter plot and see what is the strength and what is the direction. Because as they get weaker and weaker, then it starts getting more and more scattered. So you're like, I can kind of see that this one's positive, or maybe it's negative. I don't know. I could see either way. Well, this will give you a clear indication. So you're given the formula here. You will not be asked to use this formula. Okay, it's provided to you on the formula sheet. Okay, on the formula sheet, you'll see right down here. That is this formula. So it's provided to you on the formula sheet. I've never ever seen a question where they ask you to calculate it. You would not be asked to do that because your calculator will do it for you. So, but it's there. Some people just like to see, well, how does the calculator get that number? So if you're one of those people that wants to see how it works, this is how it works. You'll notice this X bar and Y bar. This is the mean of all the X values, of all the X part of the order pairs. And this is the mean of all the Y values in the order pairs. That X, Y, that ordered pair for X, the mean of X and the mean of Y as an ordered pair is always, always, always on the regression line, or the line of best fit, as you probably called it in algebra. So that ordered pair is going to become important, and we'll talk about it more later, but just realize that's what that means. The X bar is the mean of all the X values, the Y bar is the mean of all the Y values. And then standard deviation for the X variable, standard deviation for the Y variable, all of that is in there, but like I say, this is not anything that you're going to actually be asked to use. It's just good to know. So good information. Okay, as far as over here on this continuum, your values of R are going to range between -1 and +1. Okay, it can be any value in between there. You can get decimals, you can get the integers, those 3 integers. So this value gives us some information. If we're on the negative side, is a negative association. If you're over on this side, I bet you can guess it. It's a positive association. So that tells us the direction. Is it positive, is it negative? Then the idea of the strength comes in is the numeric value. So if we're out here on the ends, between 0.8 and 1, we call this a strong relationship. Same thing over here on the negative side. So anything between 0.8 and 1, whether it's positive or negative, is going to be considered strong. If we're between 0.5 and 0.8, these values in here on either side, these are our moderate values. If you get a value here in the middle, between negative 0.5 and positive 0.5, we call that a weak relationship. So once you know the value of R, your correlation coefficient, that will tell you about the strength, because it's going to be one of these, depending on its value. It will tell you about the direction, because it's either going to be positive or negative, and we will have checked the scatter plot to see if it's linear or nonlinear. So that's going to give us all of those indicators that we looked for when we were describing the relationship of two variables. So now that we know what to do with the value of R, we need to know how do we get the value of R. So this next part is going to tell us how to do this on the calculator. So first thing you want to do is make sure your diagnostics are turned on. So I'm going to show you how to do that on each of the different types of calculators, because it's slightly different. If you have this type of calculator, when you hit mode, you're going to see down here there's a place where it says stat diagnostics, and it either says off or on. You want to make sure it's on. So if yours is over here on off, if it's like that, you'll just go over to on, hit enter, it'll toggle it over, and you're set. Then you can just do second quit right here, and it's set. You're good to go. If you have a calculator like this, where when you hit the mode button, see, this one doesn't have that. It's not an option to have that stat diagnostics. If yours is like this, where it doesn't have that, here's the way we're going to do it. Clear out of there. We're going to go down here. You'll see where the 0 is. It says catalog in the blue. So second catalog, and it's going to give a list. This is every operation the calculator does is listed in this catalog, and they're in alphabetical order. So we want to scroll down to get to the diagnostics. So it's going to be under D. You can see how it has that little A up there? That tells us that our alpha keys are on, and you can see along the keys the letters. So I can see the D is right here. If I hit that, it's going to take me down to the D. So that'll kind of let you jump forward. And then you'll just hit your down arrow till we get to diagnostics on. And then just hit enter. It hasn't turned it on yet. You want to hit enter again until it says done. If you don't see done, it hasn't turned it on. Okay? So make sure that's so. Either that should take care of either kind of calculator that you may have. Once we have done that, we want to enter this data that we have over here into L1 and L2, which if you need to pause and do that, go ahead. I've already entered this. You can see there's my data in my L1 and L2, so I'm going to go ahead. So then we go to stat. Just hit your stat button. And over to calculate. And then we do number 8, LinReg. So you can either scroll down to number 8 or you can just hit the button 8. Okay. And now we're going to do L1, L2, and then we're going to calculate. So we'll see here, there's my value of the correlation coefficient. So this is what your screen should look like. if yours does not have this, if you did not turn on your diagnostics, you would only have the lines A and B. You would not have R squared and R. Okay, so that's why we have to turn on the diagnostics, because without that, you won't be able to see the correlation coefficient. So there's that value. So this one right here is our correlation coefficient. So over here, where it says what is the value of R, we can see that this value of R is 0.8019. So we want to say, well, what does that tell us? So if we look back at the top, we have a positive value that's a little more than 0.8, so that tells me I'm over here in this strong relationship. So this is telling me it's strong. Now, I don't know if it's linear. So in order to actually use this, I need to look at my scatter plot, and I need to see, does this look linear? So this one, yeah, this doesn't look too bad. I'm going to change that so you can see it better. So there we can see, it does look like it's got a pretty linear trend. We can see that it's a positive, it's going in this direction. So it doesn't look too bad. It's not perfectly linear, but we don't have very many data points, so we're still okay with that. So since it does appear to be reasonably linear, then I can go ahead and say this value tells me that I have a strong positive linear relationship between X and Y. So you don't want to forget to use your scatter plot to check for the data being linear before you start using R to interpret. Okay, so let's look at properties of R. These are questions that often come up as a multiple choice type thing, because they want to know, do you understand how to use it, how it's used, what to expect from it, those kinds of things. So these are often the multiple choice section. So first of all, the sign of the correlation coefficient gives the direction. So if R is positive, then it's a positive relationship. If R is negative, it's a negative relationship. So that's one of the things R can do for you. The value of R is always between -1 and +1. So if they give you something that's not between there, that's not a true value of R. So that's something that they may do. Fill in several different options and say which one of these could not be the correlation coefficient, or which one of these could be. And so you're going to check to see, is it between these numbers? Well, what happens if we switch where the X and Y are? What if we graph these and then we said, oh, wait a minute, I should have had the other variable as the explanatory. So how is that going to affect the value of R? Flipping the X and Y variables has no effect on the correlation coefficient, because either they're both increasing at the same time, or they're both decreasing at the same time, or one is increasing while the other is decreasing. Switching those around makes no difference at all. So then, yeah, no effect when you switch them. Correlation has no units. So it doesn't have units. There's no units to report with correlation. So since it has no units, correlation is not affected by changing the units. So if we change the units of X, if we went from centimeters to inches, that has no effect. So changing the units will not affect the correlation at all. Next, the correlation measures the strength of a linear relationship only. We've talked about this already, but that's an important thing. You always want to remember that you still have to check your scatter plot. You still have to check for linearity before you start using the value of R. Correlation is non-resistant. So non-resistant to outliers. We talked about resistance before when we were talking about describing distributions, and we talked about the median and the IQR. Those are resistant to outliers. They're not affected by those things because outliers are usually out at the ends of a distribution, and neither of those things are affected by those. This is kind of like whenever we talk about the mean, we talk about the standard deviation, those things that use every single data value in their calculation. This is non-resistant. So putting an outlier in there is going to change the correlation coefficient. The further out the outlier is, the more drastic the change. It can make it look like a stronger relationship, or it could make it look like a weaker relationship. And we'll talk more about that later, about what the outliers actually do, but you need to realize that it is non-resistant to outliers. Outliers will have an effect on the correlation coefficient. The last thing, correlation is only appropriate for quantitative variables. It would be inappropriate to calculate a correlation coefficient for categorical variables because it's not even appropriate to calculate a mean or a standard deviation or a median or anything like that for categorical. So those types of calculations would not make sense. So only for quantitative variables. Okay, so at this point what you're going to do is you're going to attach this into your notebook. So this is going to go in your notebook on page 90. Then you're going to ask the substitute for your set of cards to sort at your group. So your group should work on this together, and you're going to sort the cards into groups according to what do you think is a positive relationship, what would be a negative relationship, and what would have no relationship. So once you get those sorted, then you're going to call the teacher over and ask her to check them, or ask him to check them, and see if you're right. If you're not right, then continue until you get them correct. Once you've finished with those, then you're going to do your problem set. So you guys have a good day. I will be missing you, but I'm sure you guys will be fine without me.